question, please. Yeah.
What do we think of Belarus as a space-faring nation?
Is it already a space-faring nation or not?
Well,
what does it mean, space-faring nation?
So while I understand that some people may choose to say that having your own launch ability is part of their definition, I would argue that Belarus is already a spacefaring nation. There have already been a number of Belarusian citizens in space. There are currently Belarusian satellites in space, and you have a very mature industry, including the entrepreneurial industry that is present here right now. And so I would say the answer is obviously yes.
I agree with Richard, but I have a little different perspective on it. If any of you have ever watched Star Trek, in that series, in that science fiction venue, they talk about warp-capable planets. So I kind of look at it this way. We are a spacefaring planet already, and that includes everybody on it. And the more that join in, the better, including Belarus.
Oh. Yeah, thank you. You see, actually, it's a quite complicated question because there are no indicators for spacefaring nation. Well, when I ask this question to Euro Commission guys, they say, well, they always use this. Spacefaring nation can apply to these or these calls, you know, participating in different, you know, instruments for national. Well, I ask him, what does it mean, spacefaring nation? Please indicate what kind of things must be for spacefaring nation. They say, well, there are no indication. If there are no indication, how do you use it? Well, abbreviation, well, how do you use it this in informal documents? You see?
So, but let me give you some understanding of the perspective of those who go first. My father, Allen Garriott, is an astronaut. He flew on Skylab and the shuttle. But he was in the first group of scientist astronauts. The astronauts before him were all test pilots. So when my father was hired as an astronaut, the test pilots did not want my father to be called an astronaut because he was not the pilot. And so they called him mission specialist for many, many years. But over the time, all the rest of us thought of mission specialists as astronauts, and so the term became used for mission specialists also. Even today, since I flew privately, NASA will not call me an astronaut.
Okay.
They call me a space flight participant.
Space flight participant.
Yeah. However, I would argue that I built the company that flew me. I did experiments and commercial work professionally, so I am a private commercial astronaut. And in the same way, you should stand up for your own rights as a spacefaring nation.
Well, as for rights, actually, you know that when I said it to Euro Commission, well, I just showed them the website where Mr. Putin celebrate Lukashenko, our president, so with a spacefaring nation where we launch a satellite and where we came to UN committee. I said about this. Do you know what was the answer? If somebody said that you spacefaring nation, it doesn't mean that you are spacefaring nation. I said, well, Putin is somebody. Well,
important guy, you know, he's on the planet.
Yeah, like this.
You know, to the point, I would have to say, this time I disagree with Richard in one sense. They said NASA calls him a space flight participant. That's not exactly true anymore because NASA, over time, everything that NASA talks about eventually becomes an acronym. So he's not a space flight participant, he's an SFP. All right. But to my point earlier, as a spacefaring nation, I would like to offer you this food for thought. In 1977, about the time his dad was flying, NASA launched the Voyager spacecraft. That little probe was, if you know the story that's written in English, The Little Engine That Could, it's a little children's story about a little locomotive train engine that was small and had very difficult time pulling the train up the hill. Well, Voyager is kind of like the little engine that could, because today Voyager is still operating 39, 40 years later after the fact. It has toured all of the planets and is now in beyond the solar system and in interstellar space. And it is still operating. We are still collecting data from that probe. Having said that, I have thought about that little probe that's out there that with the technology of 1977 is still working, is out there. And I thought, long after the sun grows in size, vaporizes the Earth and Mars and Venus and Mercury, and then shrinks down to a dwarf, a white dwarf remnant star, the Earth and the sun and the solar system will be gone, but Voyager will still exist. So we are a spacefaring planet.
Thank you. It's good. Good answer. I will use the answer to others. You know that. Well. Okay. Well, probably you have a presentations now.
Yeah.
Yes. So.
Rock, paper, scissors. You go ahead. Be my guest.
Okay. Yes, please. Assistance.
Я на самом деле с трудом представляю, что я здесь делаю. Все прекрасно происходит и без меня. Но на самом деле мне сказали, что здесь будет Скотт Келли, и я готовился к его встрече, прочитал книгу его воспоминаний, а его здесь нет, а я что-то о нем уже знаю, так что я здесь буду за него, наверное. И я постараюсь отвечать на какие-то вопросы, которые, возможно, будут адресованы астронавтам и участникам космического полета. Но если это будут достаточно простые вопросы, я постараюсь просто для экономии времени отвечать на них быстро и уже на основании того, что я знаю. А там какие-то более интересные мы будем адресовать непосредственно.
На самом деле, по секрету я скажу, что я сказал, что Скотту Келли, что будет вот наш модератор такой. Он узнал его. Дело в том, что это первый человек, который на русском языке читает книгу Скотта Келли. Он испугался. Просто испугался таких каверзных вопросов и не пришел. Вот.
Книга еще не вышла, но я уже рекомендую, очень классная. Причем даже не только про американскую космонавтику, но и про российскую в том числе.
Well, first, let me say thank you all very much for having me out. It's really a pleasure to get a chance to speak with you today. Another thing I'd like to say before I get started that I was thinking about as we were settling in was whenever a bunch of astronauts get together, one of the first things that we talk about and think about, especially if we're drinking and we've already had a beer upstairs, is we talk about and often toast both the crews that are on board right now, that are up there risking their lives to bring back the science and information, as well as the families that are still staying here behind, because I know that this is can often be very tough. Having grown up as having grown up with a father that's an astronaut, I know this can be a very difficult time, also as a family. So my hat's off to you. Thank you very much for being here. But for me, I'm a little unusual in the category of already unusual astronauts, in that while there's over 500 government employees that have flown to space, I'm one of only 7 people who have flown privately under their own expense. But I flew on what was officially called Visiting Crew 15. VC-15 is my increment up in space. And as I've already mentioned, my father flew in space twice in the 70s on Skylab and in the 80s on the space shuttle. But for me, my journey to space came because one of the NASA doctors, who was our family doctor, told me that because I needed glasses, I was not eligible to become a NASA astronaut. And with a father who was an astronaut and all of my immediate neighbors were astronauts, I was crushed because I was basically kicked out of the club before I even was old enough to think about joining the club. And so I devoted myself to finding a way to get into space, knowing it would have to be privately. And I was very lucky that I got into the computer gaming business at a very young age. And with the money that I earned making video games, I began to invest in commercial space companies. For many decades, I invested in commercial space companies. And then finally, about 20 years ago, I found a formula and partners with which this worked. The ones that worked the best were something called the X Prize. I'm one of the co-founders of the X Prize. We paid a $10 million prize for the first private vehicle to fly into space, Spaceship One. We started a company called Zero G Corp that does parabolic flights. Even NASA's parabolic flights are done through my company. And we started a company called Space Adventures. And Space Adventures is actually the company that flew me and the other 6 private citizens who have been to space. And it was actually 10 years ago next month is the anniversary of my flight to space. And in conversation later this evening, I'm happy to talk about the aspects of flight. You know, the training is amazing. Of course, launch day is a phenomenal day when you put on your spacesuit, walk out to a fully fueled rocket that is creaking and groaning under the strains of weight and cryogenic fuel, and launch it into space. And then once you reach space, the view is, of course, spectacular. I spent 2 days living on board the Soyuz as we confirmed that the vehicle was operating sufficiently well for docking. We then docked with the International Space Station, which would be my home for the next 12 days. And even though it's very common that the people who've flown privately are often referred to as space tourists, I personally am not a fan of being called a space tourist, mostly because I don't think I went as a tourist. Not only did I build the companies to take myself there, but I did a significant load of scientific and commercial activity trying to pay for my current flight and to generate businesses that would pay for more flights for myself and open up access to space for more of the rest of us to be able to fly. And just as a couple of examples, an experiment that actually was my father began working on Skylab that I've continued and others have continued since is something called protein crystal growth that I think is still valuable. And as a software developer, I was going to take a large number of photographs of the Earth to duplicate photographs my father had taken on Skylab. And so I helped create this software tool to be able to see which targets were coming up next and where to look out the window to find them. And it turns out this tool was so superior to the paper printouts that astronauts and cosmonauts were using previously that this tool has now been adopted as the standard NASA tool that they use, have used ever since. Of course, there's many great things about being in space. Floating around for 24 hours a day is one of them. We were talking, one of the reasons why I got a little emotional when I was describing the family issues of being in space is at least for me, one of the profound aspects of being there was how truly isolated you are. It's very comfortable. It's room temperature, there's food and water and all the facilities you might need. But you also realize that if anything goes wrong, there is no one on the ground that can really help you in a serious emergency. You are completely self-reliant upon yourself and your crewmates to manage any of the problems that might come up. And you're in while you're in a very stable environment, you also realize it's a very fragile environment, that if something were to go wrong, it could go wrong in a hurry. And that feeling is not lost on you upon arrival. You feel this interesting comparison between comfort and isolation. It was the crew often separated into different parts of the station to work, but everybody gets back together at mealtime, which was one of the most fun times, was gathering, in the galley. But sadly for me, after 12 days of experiences, it was time to go. I boarded back in the Soyuz, which separated from the ISS. Another amazing phase of the journey is re-entry. As soon as you slow down at all, you begin to drop into the Earth's atmosphere. Once you have contact with the Earth's atmosphere, you create a blast furnace around the vehicle that begins to melt the vehicle around you, which seems very surreal, as you might imagine. And then, of course, your journey ends with an impact on the surface of the Earth. It feels like quite a serious car crash as the final step of your journey. As you actually, in my case, you not only hit the ground, but then you bounce and roll for a little while in a 6-ton vehicle. In my case, my father was actually there with me. He was with me when I boarded the rocket. He ran my mission control team, and he was there to pick me up, so that was a good father-son time. But if I had to sit back and say, what is the most long-lasting and impactful aspect of spaceflight, it would have to be something called the overview effect, which is a word I'd never even heard before my flight. But I'll take you through how at least this happened for me, and why I think that if all of you had the chance to travel into orbit, why I think it would be so impactful for you as well. You're 250 miles up. You're traveling about 17,000 miles an hour. That means you go all the way around the Earth in about 90 minutes. That means you see a sunrise or a sunset every 45 minutes. That means you cross entire continents in maybe 10 minutes. And as you look out the window, it just feels like your understanding of the Earth is going up just by paying attention. And you notice things like, this slide is to show that, if you just look up at the clouds, maybe 10 or 20 times higher than the clouds, there's not enough molecules in the atmosphere to even refract light. And so it makes you realize that there's really just not much atmosphere. There's a very limited amount of atmosphere on our planet. Oops, sorry, I'm throwing away. When you look downwards, though, you see a view that is very familiar. You see the clouds, you see airplane contrails, condensation trails, and you still feel, you feel higher than an airplane, but you still feel, intimate with the Earth itself. In fact, when you look down over an area like in this case it's San Francisco, I could see easily the Golden Gate Bridge, the Alcatraz, the Prison Island, other highways and parks. You could even see a boat, coming into the bay, and the little wake behind the boat. And I was actually quite surprised to see how much detail you could really see by eye just looking out the window. And yet, when you kind of looked out to the side, you could see not only the curvature of the Earth, but you could see how these large-scale systems would work. You could see how in the Pacific Ocean, these fronts would form and get bigger and broader, and that is probably, that's thousands of miles, across this nice, smooth, laminar curve. Whereas over the Atlantic, I would see in the shallower, warmer waters, I would see this more chaotic weather forming. In this case, it's a hurricane that was forming. As you would look down at the Earth, you would also see how the geology of the Earth had formed and changed over time. You could see the cracks in the tectonic plates, and you could, as you watch, you could kind of observe, not just in a textbook, but by eye, you could see the actual formation of those continents and how they would move against each other. You could see the results of the forces of erosion by water and erosion by wind. And these formations, they don't show up quite so well on a projector. But these are something I'd never heard of before spaceflight also, called great fans. And if you think about the sandy deserts on the earth where wind will blow the sand into little ripples, and then into sand dunes, and then into very long, multiple mile, giant waves of sand dunes. Well, what I didn't realize is that fractal change continues all the way up to a scale that you can see from space and could only see from space. And again, this is just profound in my mind to recognize the grand scale of the mathematics of the surface of the Earth. And even when you would look down at deserts and alpine areas, you then begin to notice the impact of humanity. You realize that every mountain range I ever saw had roads and paths through it. Most every river had dams on it. You would look out, and when you would cross deserts, all the continents I crossed over, deserts had roads, deserts had wells they would drill down to deep water to pump up fossil water to grow farms, and often they were running out of fresh water and having to move those farms farther and farther and farther away from the cities that they were being fed. You could see how the Earth is even being directly terraformed, where like the Palm Islands in Dubai, where I just happened to look out the window and see it and took that picture as we flew past. And then I would see things that my father had spoken about when I was a child. For example, when I was young, my father would speak about from Skylab crossing over the Amazon, where people were clear-cutting the rainforest to grow crops. And there used to be television advertisements when I was a child about save the rainforest. But I haven't seen those ads in many, many years. But then I looked out the window and you could still see it happening while I was flying. And the same thing was true across Africa. Just the entire green area of Africa was very common to have these fires. And then finally, I looked down and saw something that I really knew well, which is I saw my house. And it was very cool on like day 5 or so to look down and actually see my own home. And I saw the river and I went to the bend and I found the road and went, there it is, that pixel is my house. And as I looked, I also realized that I knew I could see Houston, I could see Galveston, my house is in Austin, Texas. And I realized I know that area very well. I've lived there my whole life. And I thought about the fact that, I've just been watching out the window very carefully for 100 orbits. And suddenly I felt like I now know the true scale of the entire Earth by direct observation. And at that moment, I had a physical reaction, which felt a lot like a scary movie where you might have a hallway with an actor in it, and they'll put a camera on a dolly, and they'll dolly the camera back but zoom the lens in to where the actor will stay the same size, but the hallway will appear to collapse around the actor. And that's what it felt like as I looked out the window at the Earth. The Earth obviously didn't change size, but my concept of the scale of the Earth changed dramatically. Suddenly I felt like I actually could embrace the entire Earth, and the Earth became sort of a small, fragile system that I felt like I understood in a way that I never had before. And while I would have always described myself as an environmentalist, this really inspired me to come back and begin to look at more data about fresh water utilization and agriculture and things of this nature. And I think that one of the things that comes out of traveling in space is really your sense of caring about this planet that we live on is really increased substantially. But I want to finish with just a few more slides talking about the future and why I think that while there's so far only been 7 private citizens that have flown, why I think that there will be more and more of us who get the opportunity to fly commercially. We're just leaving a period of time where it's very expensive and it's been very dangerous to go to space. And if things are expensive and dangerous, then people don't do it very much. It makes sense. But that is changing significantly. And the case I'll make for it goes back to the reason why other forms of transportation are much cheaper. If you look at any mature form of transportation, planes, boats, trains, and cars, generally cost 3 times the energy to operate. So if you want to pay for the car, pay for the maintenance of the car, pay for the insurance on the car, that will generally cost you about 3 times how much gas you put in it. But imagine if every time you ran out of gas in your car, imagine if you crushed the car and had to go buy a new one. Well, none of you would drive very much because it would be far too expensive. And that's what we do. That's what we've done historically with rockets, is we either destroy them or we tear them apart and put them back together to where it basically costs the same as a new one. But now we're entering this era of reusable rockets, which I think is going to bring the cost down substantially. And while I lost money on my own flight, I paid tens of millions to fly, but I earned many ones of millions with my work. Still a bad investment, other than the trip itself, which made it a good investment. But from a commercial standpoint, was a loss. But the price is now starting to come down. And I believe, and I'm an investor in SpaceX, Elon Musk believes he can get the price of access for one person to go to space down below $1 million. And even if he gets close to that, let's say it's $2, $3, or $4 million, I would have still made money on my own flight. And if I can make money, if I can be paid to go to space, I will be going a lot. And I bet a lot of you would go too. If I would pay you $1 million to go fly in space, I'll bet a few of you would go. And that's the day that I think is coming. And we're in this really fun kind of entrepreneurial phase where tons of people are building a huge amount of kinds of different strategies for reaching space. And I believe that as I've been listening in our Congress to mostly government organizations describing their plans for how the governments are going to take us to these, to back to the moon and onto Mars. And by the way, I think it does require governments to make it a mandate to go there. But I do believe that the commercial industry and private participation is going to play a larger and larger role through public and private partnerships that are coming online now. So thank you.
Да, если есть вопросы, можно поднимать руку, вам дадут микрофон, и в микрофон можно будет его задать. Так, руку я вижу, а микрофон можно передать?
Раз, раз. Раз. Раз.
Да.
Русский, английский.
Можете на английском?
Okay, Mr. Garriott, I would like, thank you for your presentation first, but I would like to ask you questions. Can you hear me okay, yeah? Okay. So basically you were talking about some ability to go to space and to be funded to do this. So what is the current situation, for example, if you're a scientist and, well, freelance scientist who wants to go to space and to be funded? How hard is that to go if you are not like NASA, ESA, or Roscosmos affiliated, and like when this will change, or will it change?
Well, my answer to that is it remains extraordinarily hard. It really did take me decades of investing to find a way for 7 people to get to space. And so I think if you are just a scientist with an idea to go to space, I don't think that will work. You have to be an entrepreneur with a compelling case to be able to raise money against to do it. And I think today that argument is still very difficult because even I don't know of a way to make money with commercial activity. But as the price comes down, when the price is into single-digit millions, and right now it's probably 20, 30 million, but we're getting close. Once it goes below 10 million, then entrepreneurs, I believe, will be able to raise money to go to space.
Sorry, but if they are not like the NASA, ESA, and just like a random group of guys that collected a sum of money and want to make some scientific, experiment.
Yes, that would work. Yeah, because SpaceX will sell you the seat. I mean, SpaceX will sell you the seat. Boeing will sell you the seat. Roscosmos would sell you the seat. The only business or the only entity that won't sell you the seat will be NASA. And NASA has made it very clear that that is not part of their objective. Their objective is that it's a national space program that is to serve the taxpayers of America. And so I think that won't change in the near term. But every other vehicle going to space is being operated as a business. And so if you have the money, they will fly you.
And is there space in International Space Station if you just like 8 people want to go there and they say no, sorry, only 2?
Short answer is today, yes. When I flew, the answer was no. And when I flew, it was very difficult to get privileges to be present on the ISS, much less use any equipment. But now it has been turned into a national laboratory. And so access is already much easier. And there are now private modules being attached to the International Space Station. For example, Bob Bigelow has a module attached. And so when he flies a full-size module, it's specifically to support commercial activity.
Thank you very much.
Сейчас мы переместимся к следующей презентации, а потом уже запасайте вопросы, и тогда уже мы поговорим подробнее со всеми нашими гостями.
All right, good afternoon, good evening. Thank you for having us here. It's a pleasure to be able to be with you, to speak about things that both Richard and I love. And I want to compliment Richard for your presentation. It's always tough to follow one of our colleagues because the experience is very similar, and Richard eloquently described many of the experiences that I had. But I will attempt to give you a slightly different perspective, and if I may, at first, before I start the presentation, is dovetail off of what the last question was about scientists. I am a scientist by background and not a pilot, I'm a mission specialist, as was talked about earlier. And Richard is absolutely correct about the future of space and commercialization. In order for it to expand to a wider population, there has to be profit in it. People generally don't respond to things very well unless there's something in it for them, the company, the corporation, and the gain. So the place in the future where I see the government space agencies, NASA, ESA, Roscosmos, and the like, is in the scientific portion and exploration of space, because science doesn't have a lot of return in terms of the more theoretical science. There's applied sciences when a company or sees an opportunity for technological advancement, there'll be investment because then they see the ability to be able to profit for it. But to explore, let's say going to Mars, to find out if there's life on Mars, there's not a lot of profit in that. That is an esoteric, a higher goal that a private company may not be interested in. And it is the scientists among the nations that request or suggest, propose to the space agencies via the scientific community that we want to do this. Indeed, the probes that we send out were, for example, Voyager, I mentioned it earlier, was a proposal and an opportunity to explore the planets. And in that case, at the time, the planets were going to align such that we could send one spacecraft, we actually sent 2, outward into space where they could go from one to the other, to the other, to the next. And we could get them all with a small investment at one time. And that was a very lucrative, if you will, not in the sense of profit, but it was a lucrative scientific goal that would help humanity gain more knowledge about itself, ultimately where we came from, where we might be going, and then who's out there with us. So in the future, and I think these space agencies are transitioning more to that role, to explore, and part of the exploration is the development of the technology to push the envelope to be able to do that. The technology to go to Mars, it's very difficult. even beyond Mars to Europa or Enceladus, a moon around Saturn, are lucrative, not in the commercial sense, lucrative scientific goals because they are water bodies, as Mars once was. And where there's water, there might be life. And if you would think about it for a moment, how humanity's thinking collectively would change if we knew we were not alone in the universe. So in one solar system, if we found life elsewhere, microbial life, if you turn over the rock and there's a fossil of an amoeba there, a microbe, on a different planet, that independently developed from life on Earth, and that potential might be on Europa or Enceladus or some other bodies in the solar system. Think about the change of thinking that we now know that there are 2 places, or maybe 3 or 4, where life definitely existed. And with the way the universe is and the expanded cosmos, when you think of all the stars and all the planets around those stars, throughout the galaxies, throughout the universe, the likelihood is very good that there is probably intelligent life somewhere else. The distances are so vast, we may never know about it, but the thought of that would, I think, ultimately bring us closer together as a community, which is ultimately what we'd hope to do anyway. So a little different perspective on the commercial use. I think commercial profit is close in. Farther out is scientific, technological advancement, and that pushing the envelope going out farther drags the commercial ventures out with it. So there's a symbiosis there, a teamwork where both are necessary. In the past, it was just governments, the space race and all of that. The commercial ventures came online, and now there's a synergy between the two that I think will happen. It's sort of like in science fiction. When we see something in science fiction, in Star Trek or Star Wars, an invention that we think is so far out, then what happens 10, 20 years after we first see it? We have that. For example, in Star Trek, they flip the phone open, Scotty, and they would have that communicator. And then lo and behold, several years later, we had the flip phones. Now the flip phones are obsolete because we got the smartphones, and who knows what will follow that. But at any rate, I'll get into my presentation. I was at the Belarusian State University, so I gave this presentation. I will be happy to share it with you today. Differently from Richard, I was a government astronaut when I was 5 years old, kind of like Richard, and the story is similar. I was, and Sputnik was launched, and shortly thereafter, Explorer 1 in the United States, and the space race took place. And at that time, I was already interested in science, in exploration. I remember as a child looking up at night at the stars, wondering what was out there, how far away that star was, could I ever get there, and my imagination would carry me into space. The space race came along, fortunately for me and all of us, I guess, is it actually had an opportunity where we were trying to get to the moon. It was a race to the moon, and we eventually got there. And now, after the space race, the space communities settled down from competition among each other to cooperation. So we have from the space race, the Soviet Union in the past, the United States, the only 2 spacefaring nations, at that time. We've expanded the envelope. We have many spacefaring nations, and that's a good outgrowth. So the beginning may not have been the best reason to go into space, and it was a political reason back then for prestige of each nation that was competing for the prize, if you will. But in the end, we all were winners out of that, because look where we are today. So I launched on the space shuttle differently than the Soyuz or even Apollo. The shuttle was an attempt at the first reusable vehicle, and was pretty good at it, but was still too expensive. But It was a workhorse. We not only did all the work prior to the International Space Station, I'll talk about that in a little bit, but we built with it the International Space Station. Before the International Space Station, we used the space shuttle in the United States to do the business of getting into space. We would carry satellites into space. Here's one example. This happens to be, if you will, a military satellite. It was an infrared telescope, not to look out into space, but to look back at the Earth. And it's infrared, so it would detect heat. Primarily in a military sense, if there was a missile launch somewhere, we would know about it. The United States, in this case, would know about it. And it was all part of the early days of the space race. And in one case, during the Gulf War, I will talk about that, the first Gulf War, where Iraq invaded Kuwait, if you remember that. This satellite was used specifically to detect the launch of the Scud missiles that were thrown at Saudi Arabia and Israel. And because it was detecting them right away as they came off the ground, the telemetry, the data for being able to intercept them was relayed to the people on the ground there. And of course, many of those missiles never hit their target, which was a good thing. So I was very proud to have been able to participate that. Still in space, still operating. I've done 3 space flights on the space shuttle, and my total time in space, unlike today where people on the International Space Station spend 6 months to a year, and maybe if we go out to Mars, it's going to be multiple years in the future. But I spent a total of 22 days in space. Richard had 12. He did 1 flight. I did 3, so I had short flights up and down. So, and on the other 2 flights that I did, we also took satellites into space. About the same size. One was a communications satellite, which NASA currently uses. It's still in space and still operational. It's kind of rewarding to know that, because I've gotten older. Like the ships I served on in the US Navy are all now gone, scrapped, mothballed, or at the bottom of the sea is an artificial reef. And the airplanes that I flew on at NASA are on pedestals, or the space shuttle indeed are museum pieces now. So it's nice to know that something I participated in is still operational. That things are getting fewer and fewer. So the communications satellite, by the way, we use it for communicating from satellite to satellite in space and then from satellite to ground. So for example, the Hubble Space Telescope, when it collects information about the universe, that data that the telescope has is relayed to this other communications satellite before it comes to the ground. And it's also used for the ISS, the International Space Station, for us to communicate with the crew on board from the ground, and from spacecraft to spacecraft if there are 2 spacecraft in space at the same time. On my second mission, I had the good fortune to do a spacewalk. I went outside the spaceship, and Richard is very much correct. It gives you a different perspective of being in space. If you noticed in this picture, in my visor, there's a reflection of the Earth. So in this photo, Earth is up, so down was actually that way. And my feet are dangling 225 miles, 300 or plus kilometers above the Earth. And even though you know mentally you're safe because you're floating in orbit and you're not going to fall and come into the Earth, we are creatures of Earth, and when we get into high places, we become cautious. If I'm standing on the edge of the Grand Canyon and it's straight down several thousands of meters, it's like, ooh, you're going to be careful. And that mental perspective you take into space. So when you look down for the first few times, you have to overcome an involuntary reaction to be frightened or to be scared. It's an education you adapt to that, oh, it's okay. This is safe. You won't fall. You won't fall. And the first time, and it has been said that many astronauts, if they happen to, early in the spacewalk, if they happen to look down, and they're not expecting to see down toward the Earth, they were turned around and they then look down. It actually scares you, as if I don't know, when you were younger, you're in school. If anybody played a prank on you, if I were standing here at the edge and it was very far to go, and Richard came up to behind me and gave me that fake shove, you know, you get a reaction like that. So one of the things while I was on the spacewalk I'd like to share with you is on the dark side of the Earth, in the shadow of the Earth, when there's no sunlight, I got a very different perspective of looking out into space. Because the Earth was not visible because it's dark, and we were over the Pacific Ocean, so there were no lights below, so I really couldn't see the Earth. And most of my visual field was the depths and the blackness of space. And it was very, very disconcerting at first, because the brain wants to know where it is. And looking out into the blackness of space was for me, looking into infinity, because I knew, intelligence-wise, that it went on for at least 13.8 billion light years from where I was. And the mind doesn't like to deal with infinity. It's a very difficult concept for us as human beings and finite creatures. And I couldn't orient myself. It was almost like you have people where they've done studies. They've taken people, put them into chambers, anechoic chambers, where there's absolutely no sound. And they seal them in there. People become disoriented because there's no stimulation of the audio nerves, and it's not good for us. There's always some background noise. Well, and they become disoriented. Well, likewise with the visual field, you become disoriented when the brain can't find where it is. And it can't find, okay, there's down, there's right for me, that's left for you, and so on. And so when I was looking out into the stars, the brain was trying to calculate, if you will, where it was, okay? And I would look down at my feet, and I knew I was attached to the space shuttle, and I saw the spacecraft there. That I did see, but that was the only thing visible. I look up, and I wouldn't see the space shuttle anymore. I'd just see blackness and infinity. And out there were stars that I could see, and I would look at the stars, and after a while, the stars appeared, this one is closer than that one. And then I would blink, and it would flip. That one's closer than this one. And I didn't have vertigo. It was just the brain trying to figure out where it was. And I found that in the end, I had to rationalize what I was seeing to myself in mathematical terms. And many of you know that, and you've been taught, that you can't divide by 0. You know, you can't have 4 divided by 0. You can do 4 divided by 2, 4 divided by 1, 4 divided by 1.5, but you can't divide by 0. And if you try to, if you give a computer that problem, it doesn't know what to do. And that's what this computer was wrestling with. It didn't know. It was like trying to divide by 0, and it couldn't find a solution. Well, I mentioned the early use of the space shuttle, and we have the International Space Station. And if you notice, this is a little later photo than the one Richard shown, because there's some more parts on it, the extra solar arrays. This is later in the construction of it. But I've often wondered, with a vehicle like the space shuttle, we built the International Space Station. And I like to draw an analogy. If you remember the movie 2001, A Space Odyssey, there was the Discovery spacecraft that we sent out to Jupiter to see the monolith out there, to find out what it was all about. But from that movie, I got the impression that we could have used the space shuttle to build not only the International Space Station, to build a Discovery spacecraft in space, so that we would be able to go out and explore beyond the realm of the Earth and the Moon. And we don't have that capability, and maybe one day we will have it back, or we will do it automatically or robotically to build the spacecraft of the future to do the exploration, to go to Mars in space. They won't be built out in the ground. We'll have to stage them in orbit before we send them out. And as Richard alluded to, we do a lot of work in space, the protein crystal growth, the experiments we do inside the spacecraft once the external mission was done, at least on the space shuttle world. But one of the things we really like to do is look out the window, and Richard showed some spectacular photographs. I have a couple more I'd like to show you. They're a little different. And by the way, you can tell this photo is getting old because the camera I'm using is a Hasselblad film camera. I mean, I know there are not too many film cameras in use nowadays anymore. Most of the photography, even today on board, is all digital. Okay, I'm going to take a little journey of some select best of, if you will, photographs. This photograph is of what I would characterize as the most colorful spot on the planet. Indeed, when you look down, it jumps out at you. The rich turquoises, the dark blues, and the hues. It's very, very distinctive. And even in satellite pictures that might be in color from geosynchronous orbit, you can see the little spot. If you look for it, if it's that side of the planet, you can see that little turquoise, blue, aquamarine spot on the planet. It is this is Andros Island. It's in the Bahama Islands off the Caribbean, off the coast of Florida in the Caribbean Sea. But I'm an oceanographer, meteorologist, and this picture has a little bit more that I would like to share with you. The term for the formation is called tongue of the ocean. You can see why. And the dark blue is actually very deep water, thousands of feet, and meters deep. And the area in turquoise, like over on this part of the photograph, is very shallow water. And it's so shallow and so clear that we are able to see the sand dunes on the bottom of the ocean in this photograph. And as Richard described in his eons of erosion photograph, where the wind ripples over the landscape and forms waves, the bottom of the ocean does as well, and we could see those formations here. Now, I will give you a spacewalking analogy for the story I just described. When you're standing out and you look down you're doing a spacewalk and you past your feet and you might see the Earth, pretend, and you could go do this, and it actually did happen to me before I went into spaceflight when I was scuba diving one time. I was scuba diving, and pretend I'm here scuba diving in this area in the shallow water. And with scuba diving, like in a spacesuit, you're wearing a mask, and you don't have a lot of peripheral vision. So I can see Richard right here. He's about at the limit of my peripheral vision. I could see what's your name? I'm sorry. I could see a gentleman here, and he is at the limit of my peripheral vision. When I have the space helmet on or the scuba diving mask, I can't see very far away to the side. I can only see mostly forward. And when I'm scuba diving, I'm swimming. And I one time was scuba diving in the Philippines, and I was swimming this way. And all of a sudden, on the bottom dropped away. And that actually startled me, because the initial reaction normally in gravity, when you see the bottom drop away, you get scared. So it was sort of the same thing in space when I first gave that look out there. And now that you know about it, you'll be aware of it if you do scuba dive. But when you're scuba diving, if you don't know that chasm is going to present itself, you'll still get the reaction. And Richard talked about sunrises and sunsets in the technical portion. This photo, Richard showed a little bit of a close-up. This shows you the extent, a little better perspective on how thick the atmosphere is and how fragile we are on Earth below it, and all there is that is protecting us. Indeed, Mars today has a very thin atmosphere. Being on the surface of Mars is sort of like being at 100,000 feet in the atmosphere of the Earth. That's how thin it is on the ground of Mars. Now, Mars, at one time or other, had a lot of water and had a much thicker atmosphere. And that's why there are the fans, the giant fans that look like river deltas. There are dry riverbeds on Mars. And dry lake beds on Mars. Mars was a water planet like Earth, which is why it is a good possibility that life may have developed there. Indeed, when we go there, we may find some. However, what happened to Mars is currently happening to the Earth, but you don't have to worry about it immediately, because Mars is about 1/4 the size of the Earth. It's smaller. And what happened there, its molten iron core solidified. It cooled and solidified. So all of that magma and iron and the heat in the interior of the planet, because the planet is smaller and had less thermal insulation, the heat eventually escaped enough of it so that the iron core cooled. And once the iron core cooled and there wasn't that liquid at the center of Mars flowing around, it lost its magnetic field. And once it lost its magnetic field, the solar wind that comes off the sun started to blow the atmosphere away. And now today, and it's still in the process of losing its atmosphere over time. So Mars' atmosphere from a once thick atmosphere became very thin. Now the Earth is bigger. We're a bigger thermal insulation, so our iron core is still solid, and we still have a magnetic field. Not to worry, it's not going to go away tomorrow. It'll be several billions of years before it does. But Mars is a model of Earth in that respect. And we don't understand how our magnetic field is generated. And that's research that's ongoing. But it is something to think about in terms of analogs for the future of exploration. I just wanted to show this close-up of the sunrise, same picture, a little close-up. It is so beautiful. The romantic side of it is the 16 sunrises and 16 sunsets each day. The romantic side of it is so beautiful and so captivating that even when we're busy at work, with certain exceptions, when we can't leave the console on which we might be working, is at least on the shuttle, because we're up there a short time, we weren't up there for years like the guys on the space station, that somebody would let everybody know, sunrise, and everybody run to the window, look out the window. And it's like, okay, because the sunrise and sunset happens much faster, so it's only a matter of seconds before it goes down because the spacecraft is moving. And then 45 minutes later, sunset! Go over the window there. And we watch the sun go down.
And you ran just like that, right?
That's right.
Like this?
Yeah, we'd run over. Well, float over on the window. A metaphorical analogy. Thank you, though. So I realize that most of us, you think of astronauts and the space agencies as all this technical stuff, and we're sometimes machine-like but we're all really romantics at heart there. That's all. Okay, some other places on the planet that are neat. This is the Nile River Delta in northeastern Africa, and Richard, can you help me? Oh, excuse me, I'll just go over here. Now, one of the things I like in this photograph is right about there are the pyramids of Egypt, and you could see things that, as Richard described, and I'll show you that in this photograph. One too many. You can see the pyramids of Egypt. It's like, wow, I didn't have to travel to Egypt. directly. I could see the pyramids from here, and it's amazing. But one of the things, I'm going to back up, it was one of those perspective things that you learn. I looked at the river delta there, and I wondered about it, because I always wondered how things got their names. Okay, sometimes we name them after, this table is the Richard Garriott de Gaillou Memorial Black Table. Okay, we dedicated this to Richard. Okay, so we've done things like that. Names are passed down from generation to generation. The name of your country, the name of the city, where did it come from? Well, in language, how did that term develop? So I looked at the river delta, and I did some research, and the Greeks, of course, were the first to of intelligent civilization to sail around the Mediterranean Sea and do the mapping. And if you know the Greek alphabet, the letter D in each delta is a triangle. And so they quickly realized, and they called it a delta. They just called it their Greek letter delta. And here we have in English, that's what we call it now. I guess, what's the word in Russian? Is it? It's the same. Okay, so you inherited it from the Greeks as we did. So it's amazing. And looking in space and thinking back to the Greeks, the archaeology, the history, there's a lot of connectivity that goes on when you're viewing the planet. A little farther east, I had, this is Mount Fuji in Japan. You can see the details looking right down in the volcanic crater. The trails that you can see going up to, if you wanted to hike up to the top of Mount Fuji. Amazing, amazing what you can see looking down in your 200 miles. Now, the physics of that is different. We're used to seeing horizontally, okay? And even when you're on the top of a mountain and you could see vast vistas in front of you, you're still looking horizontally for the most part. And you're looking through the thickest, densest part of the atmosphere, which is problematic for astronomy. We would love not to have the atmosphere as much as we need it to protect us. For astronomy, we would love to get rid of it. So that's why we put the Hubble Space Telescope above the atmosphere so it can do a much better job. Thank you. And we can do that. But when we're in space, we look, in photographs like this, we look straight down. And so, as Richard described, most of the atmosphere is very thin. Only the bottom half of the atmosphere, which in standard measurement for us is about 20,000 feet. What is that, 6,000, 7,000 meters? Most of the atmosphere is below that. The rest of it is very thin. So we don't have to deal with that, and that's why we can see such great detail. Okay, we had the pleasure of flying over Super Typhoon Yuri, and just for educational purposes, a typhoon and a hurricane are the same type of storm. The only difference between them is a typhoon is this type of storm in the western Pacific Ocean. It's called a hurricane in the eastern Pacific and in the Atlantic. So you can teach your kids that as to the difference there. We had the pleasure of flying over the eye of the storm. You can see the detail of in the eye wall of the development of the thunderstorms and where all the destructive power of these storms really lies. We also fly in space, and in this country and most of the area around here, you can sometimes see the aurora borealis, the northern lights, from the ground. In the States, where Richard and I, very rare that we can see that. We would have to travel into Canada or Alaska or come over here and go north to see this. In space, we are above the atmosphere, and the scintillation of the cosmic, the particles that come off of the sun, they hit the magnetic field and get channeled down toward the Earth and follow the magnetic field, but they don't become visible until they hit the atmosphere. And since we're above the atmosphere, we see the aurora and look down on it rather than looking up on it. Well, we've been to the moon. and we hope to go beyond the moon at some point or other. Indeed, I mentioned 2001: A Space Odyssey. That movie was made brilliantly by Stanley Kubrick in 1968. And I remember in 1968 thinking that we would be at the point shown in the movie for real by the year 2001, and here it is 2018, and we're not quite there yet. All right. John Young, by the way, was my neighbor. He has recently passed away, and we referred to John Young as the astronaut's astronaut. He was as about as expert as they get. Okay, we've been to the moon, but going to the moon turned us back toward the Earth because we got pictures like this, and we look back on the Earth now, and we realized by going to the moon that the Earth is a very, very precious place. So let me bring you home. We could take some questions. You might recognize this city. This is Minsk at night. Okay, there you go. We are keeping an eye on you from space there. And here's the photo number in the U.S. inventory if you want to grab a hold of it. But we did a little tour. We took you into space. We'll bring you home. Unlike Richard, who bounced and rolled, we did nice, soft landings on runways for me. With that, we'll bring you home for a landing, and I appreciate your attention and happy to take some of your questions.